Welcome to the sets video from mathcelebrity.com. In the next few minutes, I'm going to walk you through everything you need to know about a set. So with that said, let's get started. What is a set? A set is a collection of objects or things. Examples include letters, numbers, days of the week, fruits, and other things that you see in everyday life. Now let's talk about how to write a set or set notation. As you can see here, I've got a set 1, 2, 3, 4, and 5. In the above example, we use braces to enclose a set. In the case of infinite elements, so if we have elements that extend to positive or negative infinity, we use 3 dots, as you see right here. Sets can also be referred to using a capital letter, such as S equals the set 1, 2, and 3. Let's walk through some examples of sets. One popular example is the letters of the alphabet, the 26 letters, A through Z, as you see right here. Another example is coins, so penny, nickel, dime, quarter, and half dollar. Counting numbers is another one we covered in a separate video. 1, 2, 3. And as you can see, we use the infinity notation, the 3 dots, because counting numbers extend through positive infinity. And then we can do another example like positive even numbers. So we've got 2, 4, 6. And again, this extends to infinity. So these are a couple examples of sets and how to write them. Now let's walk through elements of sets. Each item you saw in the sets above here are separated by commas, and each item is called an element or a member of the set. Elements of sets are written using the element symbol right here. Now in the set S equals 1, 2, and 3, 1 is an element of S, 2 is an element of S, and 3 is an element of S. Next, let's talk about the cardinality of a set. The cardinality is just the count. It measures how many elements or members are in the set. So given a set S, the cardinality of the set is written like so. Let's look at an example of cardinality. In the set S equal to 1, 2, 3, the cardinality of S equals 3 because set S has 3 elements, 1, 2, and 3. Moving on, we've got a few special types of sets that you'll come to in set notation. The universal set U contains every element relative to our situation, and I'll give you an example of that in just a moment. The other special type of set you'll see is the empty set, which contains no elements. It's nothing. Now I talked about the universal set. Let's show you an example of how that's used. We're going to move on to something called the complement of a set. The complement of a set is everything not in the set but in the universal set. We denote the complement of a set 2 ways. You can pick which one you like better. You can use the little apostrophe, so S complement, or the superscript C. Either way, it's up to you, but math books and classes will use both of these ways. Let's walk through an example. Given a universal set U equal to 1, 2, 3, 4, and 5, and a set S equal to 1, 2, 3, we want S complement, or the complement of S. Well, as I told you earlier, the universal set is the set of all elements in a particular scenario. So in our particular universe, 1, 2, 3, 4, and 5, will be all the elements that could ever exist in any set that's formed inside U. So if we want the complement of S, what we're really asking is, what is in U, what is in the universe that's not in S? Well, let's take a look at this. 1, 2, and 3 are all in the universal set, but 4 and 5 are not. So S complement is just 4 and 5, the set containing the 2 elements 4 and 5, since they are everything in the universal set but not in set S. Now there's 2 types of sets. The two types of sets are finite and infinite. Finite sets have a countable amount of elements or members, meaning we can measure the cardinality. For example, the set 1, 2, 3 that we covered earlier has 3 elements, so it's a finite set. Now, on the other hand, we also have infinite sets. If you remember above, we used the triple dot notation. Infinite sets have uncountable elements because they go on forever, positive infinity and or negative infinity. Let's cover a few set notes, and I want to talk about the way sets are ordered. The way elements are ordered does not matter in sets. Now, here's an example. The set 1, 2, 3 is the same as 3, 2, 1. We don't care about the order. We can write that any way we want. We could also write it 2, 1, 3 as another example. So I just want to stress that point that the order does not matter for sets. Now, finally, here's a little gift for you, and I will put the link to this page in the video notes. Suppose you have a set and you want to learn more about it. You can either use this box or the big search box up here. And let's do our set. Use the brace notation 1, 2, 3. Close the brace, you hit return. Here's all the things you can do with that set. So you can enter any set and we'll give you all these options. And if you just click one, it'll show you everything you need to know about that set. So as we covered in the lesson earlier, here's the elements. Here's the cardinality. And then here's more advanced lessons on sets, which we'll get into in other videos. But this is cool because it will show you every single thing you ever want to know about the set you entered. So I want to thank you for watching the sets video with me today, and I will see you in the next video.